Okay, good morning everybody. Assalamualaikum. So now I will give a lecture for the chapter 3, but for the second part. Just continue from the first part. So let, let me share the slide. This is the second part of the topic 3. Topic 3 is related to transmitter. So for the previous lecturer, we studied about the amplifier, the things that to amplify the power before we transmit a signal from the transmitter to the receiver. And then we continue with the impedance matching network. The impedance matching network, the important part of this, all the slide I will underline, I put the underline. So you need to understand the part of the underline. So the impedance matching network actually is the stage on another known as impedance. The circuit used to connect when the circuit is connected. For example, we got the transmitter, and in the transmitter we have the photodetector, we have the oscillator, and also we have the filter and also the amplifier. So to matching all these uh, stage, we call it as an impedance matching network. So why we need to matching all the network? Because we want to maximize the power transfer, the optimum power transfer, which is the power transfer is required so that the data that we want to transmit, so that the data that we transmit from one point, from one stage to another stage, uh, contain enough power for the next operation. So the impedance matching network is to provide an optimum power transfer and also in the same time for filtering and selectivity. For example, we start the circuit from the oscillator and we go to the photo detector or photo comparator. Yeah, remember that? So from the oscillator got their own power and the photodetector got their own power. So when we do a matching, we want to connect from oscillator to the photodetector. We need uh, to to ensure we need to ensure that the power between this connection is totally enough for the whole process. That's the impedance matching network. And the transmitter operate on a single frequency, of course, because in the transmitter, we want to transmit a data. One frequency is just enough because that frequency is the combination between input and also the carrier. Combine the frequency become one before the transmitter. That's why the transmitter is operate in one signal. However, for the amplifier, especially class C amplifier, it will generate several frequency with the high amplitude. Amplifier is used to amplify the power, right? To amplify, to increase the power. When the time amplifier increase the power, it will generate a several frequency with a high amplitude. This will cause a radiation in the transmitter uh, system and it will reduce the performance of the transmitter. So that's why we need impedance matching network. We need to stabilize the power consumption in every single component in the transmitter system. Impedance matching network is so important. So when we do the impedance matching network, all the power in every component, including oscillator, photodetector, filter, and amplifier, will consume uh, enough power, absolute enough power so that the system will maintain a high performance with a high sensitivity and very low loss. So impedance matching network, this is the system without impedance matching network. The main idea is when we do the impedance matching network, we need to impedance from Z, impedance from input should be equal to impedance from load. So to when the impedance from input equal to impedance from load, the maximum power transfer can be done. Furthermore, it always necessary to transfer maximum. It's not okay. It's not always we need to transfer very high power, but we need to transfer very sufficient power, necessary power for every stage, every component in the transmitter. It doesn't mean from oscillator we need to transfer high power to the photodetector. No, just enough power. So to supply the enough power, to maintain the enough power in the circuit, we need to the value of the impedance input and impedance load should be equally same. So the main goal is to transfer a sufficient amount of power. No need to transfer high power, only sufficient power. Okay, this is the circuit before we do impedance matching network. This is the circuit when we do impedance matching network. There is three type of impedance matching network. The first type is L network. L network we use inductor and also the capacitor. However, the position of the inductor and capacitor is not same, depends on the situation. For example, the first circuit, the C is parallel with the load impedance, and the L is the series with the input impedance. What happened here in the first circuit, we call it as okay, this all the circuit we call the L network. But I want to explain about the first circuit. When we use this type of circuit, we put the capacitor and also the inductor in the circuit to do the impedance matching network. It will increase the value of Z load or impedance load. When the Z load is increased, the value of Z load is increased, it will increase together the Q factor or the quality of the whole system. When the quality of the whole system increase, it means that this circuit is totally good uh, for the overall function. Okay. However, need to remember the Z load, even though the Z load is higher, it cannot be exceed the Z in. That's the main idea. Okay, this is the L network for the first type. We got the L network for the second type, which is 3.9B. We put the capacitor parallel, not parallel, series with the Z load, parallel, is it? And also series the inductor with the Z in is absolutely like this for the second type of L network. What happened here is this combination will reduce the Z load value, lower the Z in. It is good. We need to remember that Z load should be lesser than Z in. However, it cannot be too less, it cannot be too low, because when the Z load is too low, the Q factor or the quality or the Q point will be very low, and the circuit will become unstable, especially when we transmit a very high data, a very high amplitude frequency, very high frequency, very high amplitude. So that's mean compared to this network and this network compared to this network, the network L network A is much more better because of the Z load. When we put the L and C like this, it will make the Z load become higher. And when the Z load become higher, the Q point also become higher. When the Q point become higher, the total circuit is very stable compared to the B circuit. When we put the C and L like this, the Z load will become lower, and at the same time the Q point is lower, and it will make the Z value lesser than Z8, and the circuit will be unstable, especially when we working with this something with a high frequency and also high amplitude. Okay, I think this is very clear. Okay, this is some of the calculation. So when we see from here, the Q factor is totally depends on the R. That's mean the resistance below. Okay, and I give you a example, so you can study from the example to make you understand about the L network. L network is one of the network for the impedance matching network. Just want to let you know, impedance matching network, we got three. First is L, second is PI, and the third is T. So most of the time we use L. Where is it? Most of the time we use the L network because the L network is very simple, and at the same time we can manage the Q point. So when we manage the Q point, we can manage the whole system. So you can study for the example. So it will help you understand what is the P network in terms of the calculation. Okay, this is the second impedance matching network we call the PI network. This is the circuit. It's look like this. We put the inductor in the middle of two capacitor and also two resistor. Is totally like this. So what could when we use the PI network, when the L network are designed, there is very little control over the Q of the circuit. The resulting Q can be obtained but cannot achieve the desired selectivity. In other words, when we use the P networks as an impedance matching network, it's good because we can manage the Q, we can control the Q compared to the L network. The L network here, we cannot control Q. We can control the Z load. When the Z load is higher, Q is higher. When the Z load is lower, Q also lower. And for the second part, the same thing happen. But in the PI network, we can control Q. We can make the Q higher or Q lower based on the load, based on the inductor. However, the bad thing is about the PI network is we cannot achieve a desired selectivity. In other words, the performance of the circuit will be less than the normal when we use PI network for the impedance matching network because of just because we can control the queue, it doesn't mean the queue is operating in the very good performance. But by controlling the queue, it will cause it will make the whole system operate in the very minimum sense. That's the better drawback or the better of it. So when we see from here, Q is totally depends on the R1 and X1. X1 is the impedance, R1 is the resistance. So the Q, that is the Q1. So there is a Q2 because the Q2 is the bit of this area, Q1 at this area. So the total Q is totally depend on the resistance. This is how we control the Q, because some of this transmitter circuit we need to control the Q. Some of the transmitter circuit we need to control the Z load or Z impedance load. Depends on the situation, but most of the time we want to do impedance matching network. It's better to use L network because the L network is more stable. Because on we can easily control the Q and control the load, the sensor. And the final impedance matching is T network. T network is used two different capacitors with one inductor. This capacitor, this circuit uh, will help the circuit to have a very stable power transfer during the circuit operation. Okay, this is the T network structure. So the main the main thing we need to understand for the impedance matching network is why we need impedance matching network. We need the impedance matching network because we want to connect from oscillator to photodetector and photodetector to filter to the amplifier. We want to do that connection because we want to transmit something. However, to do a connection, we want to make sure that all the power transmission, all the power transmit is provide optimum power transfer. So from oscillator to photodetector, enough power. From photodetector to the filter, use the enough power. Because with this enough power, all the equipment can operate properly. And there is three type of impedance matching impedance matching network. The first is L, the second is PI, and the third is T. Okay, all these totally different. All this matching network use the capacitor and also the inductor as a matching network. So the difference is how we put the capacitor and also the inductor, because the way we put the capacitor and also the inductor will give a very big influence to the impedance and also the Q, which is the Q and the load impedance will determine whether this circuit operating in very proper way or not. I think that's all for the part two. It's very simple section. Simple. Okay. I think that's only for this chapter. For the part two. Okay, we will see for the next time. Assalamualaikum.